Welcome to LF Decentralized Trust. I'm going to give an overview and updates for 30 minutes. Then Alexander is going to talk about Hyperledger Indy on Besu as a permission ledger for the EU DI wallets. And then Paulo Caldas is going to do a presentation, which is something that is really new and exciting. A lot of people don't know about it, and I think a lot of people wanted to be in the room today to see it, which is ACA-Py on Hedera. And we're going to have a little break so we can do some networking. I think there's some wine and cookies and stuff out there as well. First, I want to thank DSR, Doing Software Right. They're our sponsors. They have teams here in Porto and Braga. They have been members of the Linux Foundation Decentralized Trust and previously Hyperledger for about 4 years. And not only are they just members contributing, but they have core contributors and maintainers and engineers that support the foundation, which is really great to see. So thank you. And Claudia left, but thank you for your support for this evening. I'm not going to spend, this deck has a lot of information. This deck also has a very huge appendix of use cases and different links. I'm going to put this deck in the Meetup page when we're done tonight so that you can just download it and use it. We're an open source foundation. Everything we do is open. So it's going to be a Google Doc. Take the doc, use it as you need it, do presentations, show other people what the Linux Foundation Decentralized Trust is working on, because that's what we are. For those of you who do not know what the Linux Foundation is, the Linux Foundation for the last 20 years has been the home of the most important open source projects, I would say. Obviously the Linux kernel, which is our namesake, but other projects like Kubernetes. In the AI space, PyTorch is now one of our major projects. And we have hundreds of different projects that are really supporting different technology ecosystems as well. There is no doubt that when it comes to decentralized technologies, open source has won. What's really important to understand to really get to decentralization is open development and open governance. We encourage all companies and every individual to open source their code, to put it on GitHub, let everybody take a look at it, let everybody download it and use it. But how do you really build open development that is in a neutral, right, in a neutral foundation, that not one organization is responsible for it, and open governance. And I'll talk a little bit about that today. And that's what we're really focused on. When we're talking about decentralized technologies, we're really talking about blockchains and distributed ledgers, smart contracts, decentralized file storage, decentralized identity systems. There's a lot of projects in the pipeline right now for ZKPs, zero knowledge proofs, multi-party computation federated systems, essentially all the technologies and the different stacks that allow decentralization from a platform, from a network perspective as well as we build this out. And there's no doubt that the impact of decentralization, decentralized technologies is really reshaping the markets. And we're seeing this in modernizing core infrastructure and finance, like financial market infrastructure, trade finance, governments, digital identity, healthcare, and more. And this is just a report from last year from BCG, where the asset tokenization alone was predicted to have a market cap of 16 trillion. I would say that number is probably like 20,000. 3 months later, the number is really growing quite a bit. And we are really building what Linux Foundation Decentralized Trust is, which we're building on more than 8 years. It's going on 9 years now of communities and maintainers across the Linux Foundation that are working on these projects and communities. So very quickly, some of you know Hyperledger. Quickly tell me, what projects have you worked on? Cacti? Oh, okay. Já agora eu conheço. Cacti too? Okay. And Besu? And Fabric. Okay. So always a Fabric. I always judge as to see where the stickers go by the end of the night to see who's in the room. So very quickly, We started at the Linux Foundation in 2015. That was when Hyperledger, the project, was formed. And at the time, there was one project, which was Hyperledger Fabric, which was a contribution by IBM. It's still a very active project. And then shortly came Hyperledger Sawtooth, if you remember Sawtooth, and then Eroha. Sawtooth has been archived. Eroha is still pretty active. They're about, next week we'll do a press release that will talk about their newest release as well. Fabric continues to be one of the most used permission distributed ledgers, with V3 just coming out in September timeframe as well. The reason I put a Vovo in there is in Europe with the digital passport requirements for the electronic vehicle batteries. Vovo was the first company to get their cars off of the manufacturing lines with a digital passport. That digital passport is powered by Hyperledger Fabric. And the core company that is doing that is a company called Circular. We have a whole use case on it. So since 2015, obviously we just had permission ledgers. By 2017, we had our first digital identity project, which was Hyperledger Indy, which then gave birth to Aries and AnonCreds and some of the other projects that we have. We started bringing in tools like Caliper. In 2019, Besu, which is the Ethereum virtual machine project that we have, was contributed by Consensus, the company with the Y. I can tell you the story, and I say this all the time. It was very contentious. In 2018, when we first started talking to Consensus about bringing Besu, it was called Pegasus, into Hyperledger, because the enterprises did not want to talk about public blockchains. Literally, you would walk into a bank or walk into a big company and you would say, hey, we want to talk about Ethereum or Solidity. And they'd be like, we don't talk about public blockchains. That was in 2018. Look at where we are now. We made a big bet when we started with Besu, and now we have, and I'll talk a little bit about some of our other projects, and I'll talk a bit about Besu. But today, actually, the number is 16% as of today. Besu is running 16% of the Ethereum mainnet as an execution client, as well as being the permissioned EVM of choice for many funds. In 2019, we launched our labs. We have a great lab story, and I'll talk a little bit about it. Very early on, and it was before 2020, we understood that interoperability was something that needed to be worked on collaboratively. So at the time, it was a project called Cactus. And the reason that it's Cacti today is because there was a major contribution by IBM from a lab called Weber. And in English, if you take a cactus, two cactuses make one cacti. So we combined them together and changed the name. And then we brought in Trust over IP, and I'll talk a little bit about that. Trust over IP is now part of the Linux Foundation Decentralized Trust. It is essentially the governance standards body, and it's working on creating trust governance protocols for the foundation. Firefly and Bevel, these are tools. These are Firefly I'll talk a little bit about later on. 2022, we had Hyperledger Solang, which is a Solidity compiler for Substrate. And I remember people going, why do you want a Solidity compiler for Substrate? But there's a lot of activity right now in that ecosystem for sure. And even last year, in early 2024, we brought in Web3J. Which is one of the Ethereum libraries, and that project is very active as well. And Hyperledger Identitas, which is a digital identity project from the Cardano ecosystem called Atala Prism. So really, really diverse projects that we have. So we took all these projects that since 2015 have been working, and in September, we launched Linux Foundation Decentralized Trust. So we took the existing Hyperledger Foundation and all the projects under the Hyperledger Foundation. We took Trust over IP Foundation and created LF Decentralized Trust. And we welcomed two new projects. One is called Hyro, which is the code base for the Hedera blockchain. And the other is called Loch Ness, and I'll talk a little bit about that. So it's about growth in the industry and how these things are moving along. Like I said, a lot of these slides I'll go by quickly. The way we break down our projects, and I was talking to someone earlier and said there's so much stuff going on at LF Decentralized Trust. how do new people show up and understand where they want to go when they do? We do categorize our projects as ledger technologies, interoperability projects, integration and implementation, tools and libraries, decentralized identity, and cryptographic tools and protocols. And these are categories, and they might expand further out. These are categories, once again, that is really the landscape of decentralized technologies as we go along. You'll notice that some of the projects will retain the Hyperledger brand, and that's because that they want to retain the Hyperledger brand. Some projects, like Besu, for example, recently dropped the Hyperledger brand. New projects coming in can choose to be called Hyperledger, or they can choose to be called their own projects like Hyro. I put this in here. Just next week we'll be announcing Credible, which is a digital identity framework as well. So that's brand new. So I couldn't show you the logo because it's going to be a surprise next week. So lots of great projects that are working on here. As I mentioned, the labs, if you're interested in working in the innovation space, the labs are a great place for you to do a couple of things. Meet with other people that you might be interested in, but also bring your code projects in. So if you have code that you want to build a community around, we have a great framework, whether it's an individual or a company or an academic community, research students, and you can bring your code and we'll help you build that community around that code in the lab space. And we have a lot of tools to do that. We have internships projects that become labs. We have hackathon outputs that become labs, and production implementations sometimes that come in as labs and then graduate with our project lifecycle as well. So as I said, we have close to 50 active labs. There's more than 100. Some of them, once again, are experimentations and don't continue to grow. And there's over 300 lab maintainers, and these are people that obviously are maintainers of their own labs as well. Very quickly, when I talked a bit about open development and open governance and the importance of it, like I said, we encourage everyone to put their code in GitHub and open source repositories. Our Linux Foundation Decentralized Trust governance structure is we do have members that are part of the governing board and outreach committee and other committees and councils that are just for members. But everything that you see here is open. You never have to be a member. You never have to pay to play. You could be an individual contributor. You can work for the biggest companies in the world. Everybody has the same voice and the same opportunity to govern. All of the projects, there's a technical advisory council that sits across all our projects, and then all the projects have their own project charters and their own technical steering committees. That means that I certainly can't tell anybody what to do. The Technical Advisory Council cannot tell the projects what to do either. They need to make sure that they follow the open governance and best practices that we put forward. But each project has their own technical steering committee and make their own decisions as to how they want to govern their project. This is very important, once again, from a decentralization space, but also for these projects to really push on the edges of the things that they need for their communities as well. So I talked a little bit about our experiences in 2018 when we started talking about public blockchain. We've been using this slide since probably about 2017 and 2018. We tweak them a little bit. There's certainly not one size fits all, right? And at the Linux Foundation, we really want to make sure that communities can actively compete against each other as well, but also always under that open governance and open development best practices on how to do open source. So there's not a one blockchain to fit them all. Some use cases, you need permission, private distributed ledgers, and many use cases, you need permissionless public use cases as well. Back when this slide was started, there was only Bitcoin and Ethereum essentially that we talked to. Now the list is huge. I personally, this is my personal opinion, I don't think we need thousands and thousands of public blockchains and ecosystems. I think eventually over the next few years, we'll start seeing some consolidation. But once again, we're here to support them. We have communities in the Ethereum ecosystem. We have communities in the Solana ecosystem, in the Hedera ecosystem, and across many other Cardano, etc. When we launched Linux Foundation Decentralized Trust, I was extremely happy to welcome Hyro. Hyro is the code base for the Hedera blockchain. So it is the first public permissionless open source code base that has come under a neutral organization. Most blockchains, public blockchains, they'll have a foundation that governs both the governance of the network, the governance of the treasury, and the governance of the code. And sometimes they do split it off, but it's still under the same name. Hyro and the Hedera ecosystem really understood the importance of bringing that into a neutral organization like the Linux Foundation as well. So I'm not going to read this to you. As I said, you'll have access to this before, but we're very excited about this community, and it's certainly one of the most active right now in the space. When you think about, I mentioned Ethereum, our Ethereum ecosystem. The Ethereum ecosystem, the Ethereum network launched in 2015. That's the same time that Hyperledger at the time, the Hyperledger project. And over the years, we've had many touch points with the Ethereum ecosystem. The Ethereum Enterprise Alliance joined as members in 2018, and Ethereum Foundation joined in 2019. We've been part of the Ethereum Foundation Client Incentive Program. We have lots of projects that support mainnet and EVM support. And as I mentioned before, a lot of new projects, and we have a very strong pipeline of other Ethereum-based projects as well. And Besu is our EVM. I won't go through that, but it's important to understand kind of the market leading position that Besu has, in addition to what you see here. This is Hyperledger Besu. This is a report that Block Demon put out last year around surveyed 92 different firms, bank asset managers, financial institutions, clearinghouses, etc. And you can see here most of the decisions, most of the use cases are with Besu. If you can see this one, it says private Ethereum. There's no such thing as a private Ethereum, right? It's either going to be Besu or Quorum or something else. So we suspect that some of these numbers actually belong to Besu as well. But you can kind of see other selections as well. So Besu is very well positioned in the financial services. An important aspect of Besu is it is the only EVM client that has complete parity with the Ethereum mainnet. Why is that? Because it is running as an execution client, and it's running 16% of mainnet. So Besu has to, on a day in, day out basis, have parity with mainnet. The EVM allows for modularity, and therefore always has the best of the mainnet, but it also can have things that are very specific to permissioned EVM. So doing a really great job over the last 3 years in making sure that Besu permissioned EVM has modular approaches. There's some great blog posts on our blog around some of that work. And once again, lots of case studies at the end of the deck, but you can see how the EVM is being used. We talked about mainnet. There's L2 networks that are running Besu. Linea, for example, is running Besu. We do a lot of, our community does a lot of hybrid interop. There's public permissions, use cases, EBSI in European Union, and many others now use Besu, and then private permission ones as well. Very quickly, Hyperledger Firefly, they call it a supernode for Web3 apps. I call it as a middle layer. Essentially, it's a middle layer of tooling for people to use. And it really, once again, supports, I still have to update my logos here. It supports both permissioned and public blockchains. And it really allows, without Firefly, if you're building out a network, a blockchain network, you have to have all these considerations into place. And with Firefly, really you just, you or the companies and the networks and consortiums would spend their time building at the business application layer. So Hyperledger, again, is one of the projects that, from a user perspective, is really taken off. I won't talk too much about the identity ecosystem because the next two presenters will talk a bit about Aries. It's just good to know the Hyperledger Aries community. Some of the projects under Aries currently right now are under a sister foundation called the Open Wallet Foundation, which is where the digital open wallets are being worked on. And we'll have the two presentations. We'll talk about some of the projects that started in Aries were built out of areas and then moved over to that. And the part, when I talked about the governance, why is it important that the projects have their own technical steering committee and they have their own, they can choose, right? They can choose, we're going to take our communities, we're going to go elsewhere, and we're going to move, or we're going to split the projects. And those things are really important for open source community as well. All right, let's see what I got next. We are member supported, so the work that we do for the community is based on the members. We have our premier members, which are at the top there, many general members, also many associate members. We have some of the biggest central banks in the world really active with Hyperledger, Besu, and Fabric. In the appendix, I have a bunch of slides around central bank digital currency use cases. Love it or hate it. I'm not here to discuss the politics of central bank digital currencies, but we do work very closely with these banks. And they, you can see like the Banco Central do Brazil, when they're talking about why they chose Besu, where they talk about the principles of open source and the importance of open source and open development in their choices. Because why? They're building long-term infrastructure for the future of their country and essentially the world, right? Our children, their children will be running on these rails, and open source is really important. That is not, that has vendor diversity, that has a very active community to do that. We continue to be, community driven. I'll take a guess. How many people do you think work at the Linux Foundation Decentralized Trust? I won't say the big Linux Foundation, but what was used to known as Hyperledger and is now LF Decentralized Trust. You know the answer because you listen to my podcast. So there is 8 of us. Okay, and why? Because of our community, right? It's the developers, it's the maintainers, it's the people who chair our special interest groups, it's the people who, mentor our mentees, it's the companies who are building the products with our open source projects. That's why we are so big, right? It's the 15,000 people who are part of the India regional chapter, and the hundreds. And here in Portugal, I think the number is like 500 people are part of the Portugal Meetup community. We are also about to launch a European regional chapter, which will include Portugal and Spain and Germany, Finland, and others, to really drive once again that bigger community messes. So you're like, Daniela, can you talk any faster? No, I can't. Não posso falar mais depressa. Mas how do you find out like all these projects? Some of you are very familiar with projects like Cacti. You might be interested in looking at other projects. We do have resources for that. One is on our website. We have the project matrix, and in the project matrix you can go see the description of the projects, what the purpose is, what programming language it's based on, the language in the SDK, if it's a ledger, what consensus mechanism, smart contract functionality, token types, and compatible projects at Hyperledger. And this is really important because more and more we're seeing projects, right? Hyperledger Cacti supports interoperability with Besu and Fabric and many others, right? Besu is, and we'll be talking about, are we talking about Indy on Besu today? Yes, Indy on Besu, so you'll talk a little bit about that. And it's really important for us as a community to find the opportunities for the developers and the engineers and the companies behind these projects to work together. So compatible projects at Hyperledger is a great way to kind of say, hey, I'm interested in this one, where else can I plug myself into? People always ask us, and we've been at this, it's in 9 years. We'll celebrate our 10th year this December. Hey, Daniela, is this real stuff? Like, are there real use cases using blockchain, bringing value into it? 5 years ago, everybody used to want to put a press release out. Blockchain. Now nobody wants to put out a press release. But you know what? There's still many new implementations that are bringing value to different markets. The use case tracker that we has over 200 of these use cases. Some of them are in pilot stage, some of them are in production stage, and it'll tell you and linked out to many of the resources. If you know of use cases in Portugal that are using any of the LF Decentralized Trust projects. We'd love to have them in there and making sure that the world knows about what's happening in Portugal. If you track us on LinkedIn or on any of the social channels, we are a noisy community. Why? Because we have 17 projects, 50 labs, 120,000 participants in our Meetup community, right? There's a lot of stuff going on. How do you keep track of it? Like, how do you know what to do? If you're dedicated to one project, you know exactly where to go. If you kind of want to just poke in and see what is happening in the community, our community calendar is a great way. You're always welcomed. You don't have to be a developer. You don't have to be, an expert at a specific topic. You're always welcome to just jump in and understand what, and introduce yourselves. Every person who chairs one of our meetings or one of our developer meetings at the beginning, they should say, if they're going to go through the antitrust policy, the code of conduct, and then they're going to say, hey, new people. If you're new, introduce yourself. And it's just a great way to get involved in the community as well. We have a lot of content that you can leverage. This is all free. We don't charge for any of this work. Our workshops are a great way to start getting in depth on projects. We have workshops pretty much, every other month. We have a workshop. These are 3 or 4 hour workshops. All volunteers, right? The developers, and this one's another one that DSR did for us. The developers and the maintainers and the contributors are the ones creating the content. They're creating all the stuff. We just help with the framework and making sure that we can do the work together. We have a very active Discord. Discord for me is anxiety sometimes because there's so much, and I could literally spend 4 hours a day just getting involved in everybody's conversation or seeing what everybody's conversation is. But that's where the work is done in the community. That is, there's different channels for each project, and then the sub-project topics. And it's a great, very lively community. Once again, go in there, listen, ask your questions. There's even a job board for those that are interested in job, and there's a job postings as well for those who are hiring. We have a wiki that is open for everybody to see, where there's a lot of information, meetings, schedules, agendas, and you can navigate usually by project or special interest group or working group that's available. Highly recommend, if you're not getting this, we have 2 newsletters. One is the Decentralized Digest, which is our monthly newsletter and main announcements, events, webinars, member news rate. Once again, trying to get all that, activity into one newsletter is very work consuming, to say the least, but our team really focuses on doing it. And then we have, very importantly, if you're a developer, subscribe to the Developer Weekly, because that will give you the key things as a developer you want to know about what's happening in the other projects, even if you're not working on the other projects, and the opportunities there. Everybody, if you want to participate on the wiki, if you want to attend any of the meetings, does need a free Linux Foundation ID. This is a great tool if you're a developer. You will start having a profile and the Linux Foundation, it's called Linux LFX, around all your contributions, the trainings that you do, the workshops that you attend. Essentially, it's a portfolio of your activities in the open source community, right? And when you go look for a job, or when you go look for hiring someone, you can look at their profile and kind of see what people are working on. It's just a great way to really get involved. And here's the LF Insights, and you can track every single project. And see who are the core contributors, who's actually participating in the projects and how the projects is doing. I was talking to someone before about training and certification. As these projects get mature, we roll out different training programs, official training programs through our Linux Foundation education programs, and certifications. So we've had Hyperledger Fabric practitioner. We updated that event, last year. And we just launched the the Besu Certified Professional Cert, and that is now available. I think starting Monday, you can start scheduling the courses as well. And there's a lot of free edX courses. This blockchain understanding its use cases and applications has been taken by over 275,000 people since 2018. I tell the story all the time. I love it when the crypto bros, who are always like, I don't talk about permission and distributed ledgers, they come up to me and go, hey, Daniela, we got into blockchain because we took the intro to blockchain course, but it's a great, it needs to be updated for Linux Foundation Decentralized Trust, obviously, but there's a lot of great stuff there, including Aries, the Identity Stack, Fabric Fundamentals, and a Besu Essentials course. They're all free edX courses. We do have many vendors that support our projects. So if you're looking to partner with someone who supports our projects, for example, DSR, you can go to our vendor directory. You can go by either project, industry, or region, and you can see all these are member companies. They do have to be members to be part of our vendor directory. And these are all companies that we do due diligence because we spend a lot of time with them, right? There are members who really support the work that they do, but it's a great resource to just kind of see in the market where we have certified service providers for Fabric, and next week we'll be announcing the Besu certified service providers, and these are people that have certified engineers and gone through the process to do that as well. We talked about our global meetup community. You're here today. We used to have a very active community in Portugal before COVID, and then we kind of slowed down, but now we're back. And we want to be back very often, but it's not just about me. It's about all of you in the room, right? I don't have to come to Portugal. I come to Portugal all the time, but I don't have to come to Portugal to do a meetup. You guys want to do a meetup? You get together and you do a meetup, right? And we help support that. We have all the tools in place. And I think we're going to work to make sure that we can do some really current things. So many organizations, if you are an organization or even a university or a nonprofit, you're interested in supporting the foundation, I'm happy to talk to you about membership in the organization. But bem-vindo a todos, and welcome to LF Decentralized Trust. Look at that. 7:30 on the dot. Sorry.
Next presentation is called Hyperledger Indy on Besu as a permissioned ledger for UDI wallet. So you can see a lot of terms here, and about Indy, Besu, you've already heard. We're about going also to tell about UDI wallet, what is it, and before we jump into the main topic, I think it makes sense to spend some time talking about decentralized or self-sovereign identity. Just the very basics, because every of this actually subtopic, it deserves like hours of presentations, a lot of details, but I would like to be short and I would like to provide a general overview of the concept, because the concept itself, it's not that hard, and the details, it's a bit secondary. So, about myself, I've been working with decentralized technologies, distributed ledgers, SSI for almost 9 years. And in particular, I contributed a lot, one of the maintainers of Hyperledger Indy, RS, AnonCreds, RSA. So yeah, we know this code base very well. And about DSR, yeah, in general, we have the decentralized system department for almost 10 years dealing with these technologies. We are the members of Decentralized Trust and also Open Wallet Foundation and other foundations that has been already mentioned. And of course, yeah, we contributed a lot to many Hyperledger projects and different open source initiatives. I think it's almost 100 different initiatives. So let's start with the decentralized identity, the main principles, the main concept. And let's start with the suppose 3 models of digital identity. The first one is centralized traditional model, when you have, for example, a login, password, at some centralized place where it's all stored, and you just put your password on the website and got in. The second type, it's so-called federated identity. It can be based on OpenID, OAuth, protocols, and in terms of UI UX, something like login with Google, Facebook, whatever. A bit better UI UX, but still quite centralized on that identity provider level. And the third type, the centralized identity or self-sovereign identity, it's a new concept. And the key difference is from 1 and 2 that it's peer-to-peer. There is no need for centralized intermediaries, no need for passwords, and the main thing that it's up to the users to have the ownership of the data and decide with whom they're going to share it. who has access to this data. What is very important, this is rather a concept, it's an approach, it's not tied to specific technology, and as we will see on the next slides, there are a number of different ways, concrete ways how it can be implemented. Right? But what's important is the concept. And it focuses on privacy, of course, and there's multiple different frameworks, standards, tools, specifications. It's quite useful usually to compare the centralized identity with a federated identity like OAuth, OpenID. We can distinguish three roles in both systems, like issuer, holder, and the verifier. And usually in the federated identity in OAuth, for the verifier to get some information about the holder, you see this arrow. It's possible to contact the issuer. So there is an arrow from the issuer to the verifier. But in self-sovereign identity, in decentralized identity, we don't see it. You can see that the data comes from the issuer to the holder and from the holder to the verifier. That's a core difference. And in order to better understand the concept, let's consider the concrete example. Of course, it's an abstract example. So let's assume we have Alice, who plays the role of the holder, and she can install a certified mobile wallet application, on her phone. And let's assume we have the government who can issue a digital ID. It can be a mobile driver license or a passport or whatever. And this ID is stored on the Alice's mobile wallet. It's very important. It's stored right on the wallet, on the device. And then Alice is getting on the airplane and she needs to present her ID. And instead of presenting some physical documents, a passport, she can present her digital ID in a form of the mobile wallet. And what is important here, as we can see, that the Alice is the full control of full ownership of her identity, and she decides what parts to present, what to disclose, what not to disclose. Of course, as I said, it's a concept. The centralized identity is a concept, and we consider it an example, and we can generalize it. We can consider offline proximity use cases and online use cases. For example, when Alice comes to the gate, like physically, or when she buys something in the internet, the same principles can apply. Issuers can be any entity, not only governments. It can be business, it can be even individuals. Verifiers also business, governments, individuals. Like a common use case, well, maybe not a common, but one of the use cases when a verifier can make an individual that you want to prove your profession, for example, that two persons, they meet, they have mobile wallets, they can tap and prove, for example, that this person is a real doctor, for example, like a certified doctor. Wallet can be provided by a government or can be a third-party application. At different types of the wallets, it can be mobile, it can be web, it can be custodial, non-custodial, cloud, hybrid, and so on. Issue credentials. In our example, it was a passport, but it can be literally anything. It can be, for example, a customer credential. It can be transport tickets, concept tickets, medical records, bank data, etc. And also, there are some nice properties that can be associated with this. For example, selective disclosure. You can disclose not the whole information, but only part of this information. So, for example, that you're over 18 or 21 years old. That's it. Everything else won't be disclosed. Okay, as for the concepts, we already mentioned verifiable credentials a bit. So, it's the first one of the main concepts in decentralized identity. So, what is verifiable credential? Basically, like in real world, we have some physical documents, is a digital documents, so it's a set of claims, which is signed by an issuer, the digital signature, and it's stored on the holder side. You can see again these three roles: issuer, holder, and the verifier. And the credential is signed by the issuer, stored on the holder, and it can be presented to the verifier. And the second concept is decentralized identifiers. The core thing about decentralized identifiers that, in contrast to typical federated identities, they can be decoupled from centralized sources. And the centralized identifier, it's the identifier itself. You can see the specific stream, and you can see the method, which defines where exactly this the ID can be resolved. What does it mean resolved? Usually there is a document, a set of data, metadata associated with the DA83. It can be some public keys, it can be some service endpoints. There is a dedicated standard as part of W3C. And the third concept here, which is present in both verifiable credentials and DAD, is a verifiable data registry. In case of verifiable credential, as you can see, you need to store public keys, for example, somewhere, the public keys that issuer used to sign the verifiable credentials. And this abstraction, it's called verifiable data registry. And the same for DAD, this document, it needs to be stored somewhere, right? This abstraction is verifiable data registry. What is important? It can be actually anything. It can be a database, centralized database, it can be web-based, it can be X509 certificates, and of course ledgers, public ledgers, private ledgers, permission ledgers, layer 2 solutions, but all can be valid options depending on the use case for the verifiable data registry. What is important here, we need to understand what is usually stored in the blockchain, for example, on the ledger, and what is never stored on chain. What is never stored is the verifiable credential itself. The verifiable credential is always stored only on the user side. It is not put on chain. And of course, private keys. What can be or usually stored on the ledger, it's the issuers, public keys, and kind of revocation registries, information about the credential schemas. Usually it's public information. Okay, and now let's combine all these concepts together. Again, we have this issuer, holder, and the verifier. And what we can see that the issuer digitally signs attestation, some claims, verifiable credential, and usually it signs it by a key associated with a DAD, issuer's DAD, DAD1 in this example. This verifiable credential signed by DAD1, it's stored on the holder side. And then the holder can present this verifiable credential to the verifier. Usually the credential is associated with some DAD or DAD2 on the holder side. This DAD doesn't need to go to the blockchain, it can be a pairwise DAD or key, JIT key, for example. And while this association is needed with DAD2, in order to have some proof of key possession on the holder side, and the verifier can make sure that this credential was actually issued for this holder, that he really owns these claims. And verifiable data registry, you can see the issuer can write, for example, public keys or some public registries, and the verifier can read these keys in order to verify the signatures. But there is no direct communication between the verifier and the issuer. So, for example, every time when credential is presented, issuer has no idea that it happened, that it's intentional. Issuer can even be offline, right? As long as verifiable data registry is available. And in case of blockchain, that's why blockchain is or ledger is a good option for this. It's decentralized trust for all these public keys. And I really like this another way of this abstraction. I call it interoperability variables. So when we are talking about centralized identity, again, it's a concept. And it's important to distinguish three main parts here. The first one is what? Verifiable credential format and signature types. We understood that verifiable credential is just some claims like a digital passport, but how exactly it's encoded? What kind of digital signature is used, right? Multiple options. There is W3C standard, and there are also some sub options here. So for example, standard JWT, JWT, it's a valid option for a credential. We can consider Hyperledger AnonCreds. It has their own format. Actually now it's compatible with W3C VC. We have SDJWT VC. It's one of the format being used currently, for example, in the European Union for UDI wallet. We have mobile driver license. It's a standard which gets a lot of adoption in the US. We have carry standard ICDC. So lots of different ways how exactly it can be represented. The second thing is how. Verifiable credential exchange protocol. It answers the question how exactly verifiable credential comes from the issuer to the holder, and how exactly it goes from the holder to the verifier. And a set of different protocols. We have Hyperledger areas and JIT-based protocols. We have OpenID for verifiable credential, a protocol which gets a lot of adoption nowadays. We have W3C VC API, it's REST-based API, and so on. And finally, where? DAD method, the type of the DAD, and the VDR. Where exactly the public keys are stored, how exactly the trust is achieved. And here we may have options with a permissioned ledger, permissionless ledger, some layer 2 solutions, web-based, self-certifying solutions, and so on. This is a screenshot from a simple Trust Power IP stack. It has multiple layers, and you can see that these variables they can map to this net. So we are talking about the solution for decentralized identity. It's usually very important to answer to all these questions. So for your solution, what format are you going to use, what exchange protocol, and where you're going to root your identity in terms of the trust. Okay, now a couple of words about UDI wallet and ES2, since we're all in Europe. And very critical trigger for adoption of decentralized identity is actually regulation and adoption on the states level. And the European Union, they've chosen the approach to apply decentralized identity principles to all the residents, all the citizens, to business. And what they're going to do, they are going to allow every citizen to be able to use a personal digital wallet, to identify themselves, to be used in online, offline scenarios, to public, private sectors. And here's a short timeline of how it happened. And probably the most important events happened last year. The European Commission released the initial reference implementation, and it's actually this whole regulation, it's entered into force last May. And it means that by the end of 2026, every member state will have to provide this digital identity wallet, UDI wallet. That's quite important, and it gives a lot of adoption for the whole concept. Of course, it's happening not only in Europe, in Canada and US and Bhutan, for example. It's also applied on the state level. But yeah, it's important to understand. But yeah. Okay, finally, let's discuss Hyperledger Indy of Besu. But before, let's understand every of these that works. So let's start with Hyperledger Indy. They already gave a good overview of the project, just some general overview. Historically, Indy consisted of multiple parts. The ledger part is a public permission ledger, and it has its own consensus implementation of the consensus protocol, and the whole framework for the ledger. And also there was an SDK, like client SDK written in Rust, different wrappers. So basically, Indy was implementing all three layers back in 2017. And it was the very first adoption and implementation of AnonCreds format for verifiable credentials. So eventually, the monolith of Indy was split to multiple projects. So we had Hyperledger Ursa. It used to be a shared crypto library for all Hyperledger projects, and it was based on Indy Crypto, it's part of Indy initiative. Then we have Hyperledger Ares, where parts of Indy SDK, the SDK library related to wallet, and to the protocols, so the specification, we moved there. Then we have Hyperledger AnonCreds, which is a specification for the AnonCreds standard, because of course AnonCreds, they can work not only with Indy, but with many ledgers that we will see for the next presentation, how it works with Hedera now. And finally, in 2023, we got Hyperledger Indy on Besu. So, why this idea to have Indy on Besu? Why we started to think about it? As already mentioned, Indy Ledger, it implements its own consensus protocol. And back in 2016, made perfect sense because there were no alternatives, and we needed a way to root decentralized identity. But on the other side, it made the code base of Indy quite complex. So of course, it was harder to maintain it, and of course, its performance and scalability maybe was not the best because of this. And also, what is important, you see in the previous slides, we have a lot of new standards nowadays related to the performance of credentials, protocols, and so on. Indy historically was related to AnonCreds, but it would be great to support other standards. So the next part, Besu. So I won't probably stop a lot on it. The overview was already given. So what is important here that Besu is an Ethereum client. It has a pluggable architecture. It can be used for both private and public use cases, and depending on the use case, different set of features and types of consensus protocols can be used. And yeah, in terms of Indy Besu, we are especially interested in enterprise use cases, which can be applied to many different verticals, businesses, including decentralized identities. So Hyperledger Indy on Besu. So basically, what it's about? It's about replacing the custom consensus ledger layer of Indy with Besu. Since why don't we need to have a custom protocol if we already have proven well adopted framework for this? So that's an idea. So as a result, we have Hyperledger Besu replaced the blockchain core, and all the business logic was implemented as smart contracts. What's important that it can, as existing Indy, it can work without tokens and fees. So all the same concepts and all the same principles of original Indy I place about the public permissioned ledger. And now it's part of the official Hyperledger Indy repository. Moreover, it's even part of the official did Indy method. So it's a valid option, and I'll tell about real-world adoptions later. So yeah, that's how we have the code is there as part of Hyperledger. There is a separate repository Indy Besu. And as for the technical details, the transactions in the identity business logic is written as Solidity Ethereum smart contracts. In particular, the logic related to DIDs, the logic related to AnonCreds, types of verifiable credentials. What is important, since we already have a number of deployments of Indy, the goal was to keep migration, to have a way for migration from the classical Indy to Indy on Besu solutions. And also Indy on Besu implements a number of unique features of original Indy public permissioned ledger, for example, transaction endorsement policy. So it's a way to write to the transaction even if the writer doesn't have right access, it can be endorsed for some parties. It's quite a nice feature for permission ledgers. And this code has been integrated with Credo. It used to be part of Hyperledger areas. Now it's Open Wallet Foundation and with a number of different frameworks. So another benefit of Indy on Besu, it supports more standards than original Indy. So original Indy was only about Hyperledger AnonCreds standard, but now it supports not only AnonCreds but also the common W3C verifiable credential format and different types of signature as a result. And as for DID methods, it supports DID Indy. There is an extension of DID Indy, DID Indy Besu, and DID Ethereum. It's also supported. It's a well-proven method for permissionless cases. So both methods are supported, and depending on the type of deployment, DID Ethereum can be preferred for permissionless cases since it's better in terms of cost and gas. And DID Indy can be good for permissioned cases because it supports legacy, DIDs, it's fully self-managed, and it supports some nice features for pipeline. So, as for the components, it's pretty standard. It's similar to the legacy Indy. So we have the network, the deployment, which is based on Besu, and we have deployed Solidity contracts, and we have the library, the SDK, which is written in Rust. And we have a number of language wrappers, Python, Node.js, Besu, and so based on C callable API. And in terms of smart contracts, there are some smart contracts for DID-related logic, for at least legacy. It is supported in DID Solve or DID Indy Besu, DID Ethereum, and a set of smart contracts for AnonCreds, for schema, credential definition, relocation, and so on. And also, it extends the permissioning logic by adding some upgrade control, validator control, account control, and so on. And also role-based permission, similar to existing Indy ledger. So there is a number of real-world applications of Indy Besu. For example, in Brazil, especially, already have heard that Brazilian central bank they've been using Indy. They've been using Besu as a solution, and it's quite natural to extend a Besu deployment with identity capabilities, which is why we have Indy on Besu, right? So a nice feature about Indy on Besu that it can easily be integrated into any existing Besu deployment. It can be a, for example, CBDC solution, or it can be a supply chain solution, or whatever. So yeah, in Brazil we have two use cases. Also, it's also supported in the various toolkits. For example, in DSR we have SSI toolkit, which supports multiple standards. It's quite modular, and in Besu it's one of the options for VDR to root identity, referable credentials, and DAs. So as a summary of benefits of Indy on Besu, so it's an option to root decentralized identity on a permissioned ledger, which is similar to existing Indy, and it's quite important that it doesn't require any crypto, any fees, because it may not be acceptable in all the cases to root identity on a public permissionless ledger. In many cases, a private ledger is more preferable because it can has its own governance, its own deployment, and so on. So we have the proven use cases, proven adoption, and we're addressing the same use case but with a nice benefits. It's open source, it's Apache 2 license, it's part of Hyperledger now, LFDT. In terms of technical details, it reduces the code-based complexity a lot. So if you compare, it would be nice actually to have a statistics about number of lines of code in the original Indy and the Indy on Besu. I think the difference is huge. So it's simplifying the maintenance, simplifying the usage of the code base. Also, we have improved performance, improved scalability, and stable blockchain core thanks to Besu. As a result, reduced cost of operating, of deployment of the nodes. And also, one of the goals was to have compatibility with existing solution, clear path for migration, and multiple ways to deploy it. It can be done for permission use cases, for permissionless use cases, and compatibility with modern standards, for W3C VC standard, for W3C DID, and so on. And especially due to the last thing, Indy on Besu can be potentially qualified as a trust service for UDI ADS. Because right now, this question, what ledgers can be used for UDI, it's a bit open. Of course, there is ACA-Py. Maybe someone have heard about it. By the way, it's also based on Besu in particular. And Indy on Besu, yeah, it also has quite high chances to be qualified because of the same technology, because of a very simple concept, and also a nice benefit that it is a code and different deployments can be done, and with their own governance, with their own specific. And maybe for those of you who have heard about Sovereign, Sovereign was a very fast deployment of Indy. So Indy is just a code base, and Sovereign is like an actual deployment of Indy. But unfortunately, Sovereign, the end of last year, stopped its operation. So maybe it can be a road to move forward with the Indy on Besu or similar solutions. Yeah, that's it. Almost in time. Thank you. Hey, please, can have a couple of minutes. Rick.
I have a question. Can you go to the previous slide, please?
This one?
So when you say that can be qualified as a trust service for EIDAS, does that mean that EIDAS regulation is moving away from the federated approach and also incorporated the self-sovereign approach?
In terms of the VDR layer, it's still an option. It's still an option. They don't have a very clear qualification yet. It's being discussed, it's in progress, but they're considering different approaches for example, where to store public keys, including Ledger. So Ledger is mentioned in IDEAS 2 and so on, but it's still kind of in progress. Yeah.
And a follow-up question, you mentioned previously that there is this concept of a digital identity wallet. Does that mean that it is a wallet to store attributes, identity attributes, or is it foreseen to have some kind of integration with financial attributes?
It's mostly about decentralized identity, like a classical 3 actors that we have here, right? So we have a holder who can store and manage credentials, verifiable credentials, and there is a need for application, and this is exactly this wallet, it's about it. So in principle, UDI concept in terms of this model, they are fully compatible with decentralized identity, with software identity. This layer, verifiable data registry, yes, it may have some specific, and for example, the usage of DID is currently kind of optional there, so it's not mandatory, it depends on the profile. But yeah, the wallet is actually the application, can be mobile, like a web wallet, where verifiable credentials are stored, but they're stored locally, right? So it's up to the user to present them, to have the full ownership. Okay, thank you.
I have a question regarding the timeline that you showed a couple of slides later, where it says that the European Union is expected to have everyone by 2026. Do we know where Portugal currently stands there?
Yeah, it's a good question. So Portugal, well, there is a number of so-called large-scale pilots. It's like big consortiums of multiple vendors and projects devoted to different use cases. For example, there is a consortium devoted to traveling or some healthcare or social security, and Portugal is a member for some of them. So it's been working together with other states on this field. I would say that what exactly Portugal has been doing here, it's not as open as, for example, Germany, because in Germany they have a lot of visibility, they have a lot of, public architecture reference frameworks available for everyone for review and so on. For Portugal, it's not like this, but yeah, we'll see. We'll see. Of course, this date, some people think that it's too optimistic. Probably it is, but we'll hope. And also, many parameters of this framework, they can be up to the state. So in some states, probably they will have just one wallet created and owned by the state. Some states may be quite open to competition, so there can be multiple wallets created by private companies. So for example, in Germany, they decided that there will be a way for private companies to create their own wallet and to be certified. So there will be like a market, a competition. So yeah, it's up to every state to decide probably these nuances, but we'll see.
Hi everyone, I am Paulo and I am a backend developer at DSR Corporation. And I kind of wanted to talk to you about the work we've been developing and on which I was considerably big contributor in terms of code base, which was the Hedera ACA-Py plugin. I am very happy to be here. Actually, I love Linux. I use the Linux operating system as soon as I found out what it was, maybe like the last year of high school. I could have started sooner, but I didn't know about it. But I really enjoy it. I like the idea of open source, of people coming together and developing code in a way that is to help the common good, to kind of contribute in a way that is, altruistic to everyone, to help everyone. And in the concept of decentralized applications, decentralized solutions, it becomes paramount. It becomes a requisite that these things become open, right? You cannot trust a solution if you aren't aware of what is being done under the hood. So for me, it's very good to participate in such an event, and more so to contribute code myself. I've been using, all of us probably, I've been using in some way or another contributions that came from open source. So it's good to actually be contributing code in that essence. Okay, so the agenda right now, there's a lot of concepts that I will go over during the presentation. I'll kind of start from scratch in some of them, kind of build up some concepts just to see if we're on the same page. Probably some know a lot about them, some you kind of want to see what it's more about, but I'll start laying the foundation. First, talking about something that was discussed right now, or a little bit before, the Hyro project, what it's about, because it has big consequences for our solution. Then we'll talk a bit about Hedera. It was discussed already. I'll kind of give you an overview, what it's generally used for, some of the advantages associated with it, why it was important and a good use case to be incorporated into the solution we developed. Then we'll talk about ACA-Py, same thing, what is it, some of the properties that make it suitable for our solution, and then we can talk about the ACA-Py plugin architecture. This is because we have developed a plugin that incorporates into this. So I think it's important to give you also a developer overview perspective on things and how they made it so to incorporate different plugins in such a way that they can all interplay together in a way that does not cause disruption, and it causes easy and fast adoption and development. Okay. So we'll talk about ACA-Py, the plugin itself. That's the main part of the presentation, which is what we actually developed. Same thing, what is it? I'll give you an overview more architectural wise in terms of what is the solution we developed, some possible challenges, and then integrating with the Hedera network. What are some considerations that had to be had as a developer there? And then we'll conclude with what results from this. What are the benefits for the community? What is the end result from this? And then we'll see a demo, not a live demo, a video, because live demos are usually very scary. Okay, Project Hyro. I'll be talking about Hedera after, but the important thing is that Hyro is the open source visualization or representation of Hedera as a solution. It contains the source code, so helper functions, some utility methods, and the general consensus algorithm that powers Hedera. So this in theory would help you build your own ledger if you so desire. Nothing would stop you also from using Hedera itself, that network, as it is already very mature and has wide adoption from big players. This is a quote from the president of Hedera itself, saying how this does, and it does, represent a big step, because now this very mature technology becomes part of the open source. And like we said, it's a necessity to power decentralized applications that they are open source. So Hedera becomes part of this big umbrella of Hyperledger and as a consequence of decentralized trust umbrella of technologies. So we add a new type of ledger into it. We'll talk about why Hedera specifically kind of distinguish itself from other ledgers. And it kind of became a natural adoption, as the Linux Foundation is in of itself a trusted brand, and it kind of makes sense in a way to power decentralized applications. You now have different kind of modular pieces of technology that can incorporate with each other, not so obligated to interplay with each other, but giving you many possible permutations in a way where maybe you want features of one, but for the other it kind of doesn't make sense. So it gives you very different pieces that play along very nicely. Okay. So what is Hedera? Depending on how you search that online, you might get different answers, because Hedera is first and foremost the company, which it has headquarters in Dallas, Texas, if I'm not mistaken. But it also develops Hedera, the technology, the network, which is in of itself a ledger, a public ledger. So it's a place where you can store data in such a way that requires a big amount of entities to come into accordance, to reach a consensus, about what that is. So it becomes decentralized. Okay. The comparison with blockchain is very natural. I can kind of think of this as a reimagining of blockchain, as a new version of how it works. Instead of being a linear chain of blocks, it is a hash graph. That's the technical term that defines Hedera. So Hedera is the network. It's an instance of an hash graph, so to say. Hash graph would be the technology. An hash graph would be a acyclic, so it's DAG, directed acyclic graph, and it creates the graph, multiple nodes. Each node belongs to this network, and they keep neighbors, and they talk to these neighbors about the information that they are passing through. The idea is that if you split these neighbors and they talk enough about information, the technical term that Hedera says is to gossip about gossip, you can reach a consensus on information in a way that is decentralized. They distinguish themselves from blockchains by saying that they are incredibly fast. This would be in terms of number of messages, transactions that they can process per second, and they are comparatively. As they are proof of stake, they are energy efficient, and by their decentralized way of operating, they are secure. So it serves as a underlying data layer to store your data in a way that is actually quick, secure, distributed. So this becomes one piece of the puzzle of the solution we're going to develop, is Hedera as a ledger technology. So here's a graph kind of displaying some of the players. You have the consensus network here, where different nodes, they are trading information about each other. They are saying what messages that they are received, and they are talking with their neighbors between them. They are gossiping all the time. It's inherent to how this works. And then you can build things on top of it. You can build a consensus service. So you can ask it questions about a piece of data, and it can tell you if they have reached the consensus on what that data is. So it becomes a kind of a database whose transparency and decentralized point of control becomes actuated. You can have a token service on it, so you can have NFTs on that as well. You can mint them, and you can have them reside there forever. And you can build smart contracts on it. You can build solidity-based smart contracts, and they can run on it. So it's a more of a general purpose, let's say, way of storing data as a ledger technology. And then many applications can be built on top of it, such as assuring content authenticity, like was mentioned before, for the batteries of the cars. Or maybe you have this huge supply chain of different, let's say, food suppliers, and food comes from all over the different countries to different suppliers. You want to have an audit log of everything that goes through. You want this to be immutable, and you want no central party to control this information. You can build decentralized finance on it, a bunch of things. Decentralized identity is the one I want to focus on today, because it's the one whose solution we have developed. Interestingly, there's the Hedera Governing Council, which was also mentioned before. I find it interesting that the council was designed from the ground up to be decentralized and democratized. There's a lot of interesting rules set up. There's like 29, if I remember correctly, 29 slots, and they distributed the slots between very different types of industries, and from different time zones, from different geographic areas, and they must not reside there for more than 3 years for 2 consecutive terms, and each council seat has 1 vote. And one of the decisions that came from the council, we talked about before, the idea to actually make all the code that made this possible open source. Some of the players are very well known: Google, IBM, Dell, Boeing, etc. Okay, so let's focus on the decentralized identity use case. It's the one we want to talk about today. Kind of going off some self-sovereign identity basics. My colleague has mentioned some of them. The point is that there's this DID, a decentralized identifier, which serves to identify essentially anything that you would wish to identify, maybe a person or an object. And this must be unique per person, and it must unambiguously resolve to a document which contains important information. This information resides in a ledger. In our case, it's going to be Hedera, and it allows for very interesting use cases. Some of them you'll see in the demo. Maybe me represented by one div and some another person represented by another div can have a fully encrypted conversation, and this requires no intermediate party, as it resides in a fully decentralized data layer, but it can also be used to share credentials, something that my colleague also talked about, and I want to give some overview very quickly about as well. This div method becomes very important to have plugin functionality on top of it. I think the most well-known comparison would be when you go into a browser, you can put HTTP or you can put HTTPS. If you're in the 90s, you can put FTP or something like that. You can use, like, I think, a file if you want to retrieve it locally. So there are many different reserved keywords that you can add to the browser to kind of give it hints of different ways to retrieve data. And here is the same. A div can have many different ways to retrieve the information associated with it. In our case, we are building a plugin. We are going to use the Hedera div method. So this kind of lays the ground up of how this can work. An interesting use case of this, by the way, would be to use access control. Maybe a div identifies one specific user in a company, and you want to give different permissions to different users based on the div. And the individual can talk to this verifying party in such a way that it becomes essentially private between these two, and their assessment on whether or not they can proceed with the action can proceed as it normally would in a normal application, but it's fully decentralized. Okay, as far as the credentials go, I won't talk too much about this. We have already did, but consider one type of credential like a university diploma. Maybe this issuer party is a university, and it wants to give me a credential that says, okay, you took computer science in 2016 and you graduated. It kind of splits, it takes this triangle and it removes this direct connection in such a way that I can then use this credential with whoever I want. But most importantly, whoever wants this information, maybe a possible job opportunity. And there's some interesting use cases that come out of it. One of them is selective disclosure. Maybe I don't want to give him all my information and only one that is pertinent to the question. I tried changing my telecommunications mobile a few months ago, and I had to give them a copy of my personal citizen card, front and back, the document that should be non-transmissible and individual. So that is very weird to me. I want this to become the traditional way of doing things. We live in a computerized world. They should only require that which is essential. And another interesting use case where you can use some cryptographic magic is, what is it? You can use predicates with zero knowledge proofs to kind of assert a truth to this verifier without giving him more than he really needs. So something like, are you over 18, which is very useful in some application contexts. And why would he need to know the year, the month, the day I was born? Is it not sufficient to know that I am over 18? So these are the many interesting, let's say, solutions you can build on top of it. And this lays the groundwork of our data layer. So Hedera is going to be our data layer. DIDs and AnonCreds, let's just speak about credentials generally, is going to be pieces of data that we want to leverage. And now we can talk about ACA-Py. Okay, there's many terms here, so I want to talk slowly in some places. So ACA-Py, it used to stand for Aries Cloud Agent Python, but now they want to provide more than the Aries interoperability profile. They want to build more possibilities with different standards that have to do with identity. So now they rebranded, and the A is just A Cloud Agent. And It is an agent that runs in the cloud, and it supports some of the features that we discussed previously. So the ability to create these identities and the ability to have credentials given to you, or the ability to issue credentials to someone. And by the way, this is developed, there's nothing stopping you from using different DIDs. You are not tied to one for life. So if you want to make business with a reputable website and then another with one you don't really trust and you want to give only some piece of information, by creating new DIDs, it's analogous to creating new emails every time you want to register to a website, but it's much more quick and immediate by design. It's not something that you would even want or require to keep track of. Okay, so a lot of privacy, a lot of authentication is enabled here. So ACA-Py, it's a pre-existing project, and we built a plugin for it. ACA-Py allows running in the cloud, and it allows users to perform these operations. Maybe I am a university and I want to issue some credentials, or maybe I am an individual and I want to keep a wallet with myself where I keep some credentials. To use this, I would require something like ACA-Py. Okay. Something else I want to do, it is being currently hosted under Open Wallet Foundation. That's important to know. And we have developed a plugin for it. So more of a developer point of view, the ACA-Py project, it will be successful if it's easy to develop plugins for. And that I can say it is. It comes as an executable, and the important thing is that they gave you many options to do almost everything. You can get it as an executable directly from, so if you're using Ubuntu, you could get it from apt. I got it from Brew. You can get it from the Python package manager. You can get it and run it as a Docker container. And again, with the options, you can configure it with a lot of command line parameters. But you can also pass an environment variables. You can also pass a configuration file. So it gives you a lot of options, and it makes developer adoption quicker and bigger, I think. And a lot of other things are configurable. You can configure what wallet you use to store your credentials, or some private keys. We used Askar, but just for a proof of concept, you can swap between any other one. You can use different transports. So maybe you want to communicate with your agent over HTTP or over WebSocket, if it makes more sense for your use case. It's just as easy as swapping a command line file. Okay, so to configure and communicate with this cloud agent, it exposes a REST API that you speak to control it. Maybe tell it, issue me a credential, for example, and it can talk back to you in the form of webhooks. You can give him a webhook and he will notify you upon operations. Maybe you can be notified when someone sends you an encrypted message, on when someone issues your credential, or when someone challenges you and asks you for a credential. So you can see exactly who and what there is asked for, and you can explicitly accept or decline that. Okay, so to develop a plugin on top of it, you can see our data layer here, where we use the consensus service as a way to retrieve data and to insert it. So whoever uses our solution can create DIDs that will permanently reside in Hedera, but likewise resolve these DIDs and get information about the DID through Hedera, so we know it is permanent and it's distributed, so uncontrollable in theory. So you can start communications with this entity, or maybe issue a credential, or challenge him for a presentation of a credential. we extended upon it by adding new endpoints, HTTP endpoints. This was also made very easy. A lot of the plugin, let's say, way that they manage different plugins is by essentially doing something that Python does a lot, which have magic methods or files, things that if they exist, they trigger some behavior. So it was just as easy as creating a specific file with a specific method that tells him, okay, when you launch, also create these endpoints. So this is how we added the functionality of creating this on Hedera. To actually resolve it through Hedera, there's another, a little more elaborate, but I would say as easy of a method, which is to take an object which the main ACA-Py gives us and inject code into them in the form of a class, which needs to implement a specific interface, which essentially says, when you do see something which is div colon Hedera, run our code. We will resolve it and we will go to Hedera. Maybe another plugin will do it in another way. Maybe another will read from, I don't know, a CD or something, but we will go to a distributed ledger. Okay, Mark. Okay, so our solution is essentially what? We've built a plugin which runs on a pre-existing and solid agent for performing self-sovereign identity operations, but we did it in a way to include this did object to be stored and resolved from Hedera. That's one point. But we also did so incorporating AnonCreds. It's a type of credential which has some of those properties I discussed previously. This idea that you can give only as much as you want, not having to give your citizen card to prove something. And likewise, these are stored on this mature, fast, cheap, relatively ledger. Okay, so in terms of integrating with the Hedera network, we built an SDK, a library that you can import from Python code to communicate with the Hedera network. We kind of abstract from the callers would be here, and we kind of abstract the complicated logic that needs to exist to communicate to this ledger. We read mainly from a mirror node, and we send the data to nodes that will reach a consensus about the data. And then there's some, to make adoption quick, we want people that call this SDK not to have to deal with all the nuts and bolts that make this work. So, for example, a chunk in Hedera has a relatively small size. They do this for a reason, but the caller does not have to worry about that. It's good interface design that you make the API easy, and then you maybe you have to split the data, but they don't have to worry about that. And when they want to read the data, they just want it as a whole, and the SDK handles that. This SDK will too be open sourced as well. Same to resolve. Okay, so now we have to consider how do we put all these pieces together. We want to resolve a did, for example. The caller asks for it to be resolved, and this is part of our SDK. We provide a simple function that says, give me a div, that piece of string you saw before, and I'll give you a document. In the guts of it, they have to go to the ledger, and here we have a potential for some optimization. The Hedera company published let's say, a spec on how you should save did documents on Hedera in such a way that it makes sense. Because for one, you should be able to delete dids, these decentralized identifiers. But everything that stays in the ledgers should stay there forever. So they provide a way of essentially storing events in the ledger. You kind of create a chronological set of actions that happen to a did, maybe it was created a year ago, updated 2 months after, and deleted today, and we store that on the ledger. This gives us some caching opportunities to kind of make this a little quicker and with less load on the network. We kind of do some, I think of it of like, maybe you read a chess game from storage once, but if you are playing with someone, you don't need to get the entire game again. You kind of get iterations of it. You say, okay, I have the game up to this point, give me the next move. So it's just a way of optimizing. With AnonCreds, it's very similar. It's conceptually very similar. We do have the interesting case that a lot of the metadata that is associated with a credential is immutable, is there forever. If you create a credential definition, it stays there forever. If you want to change it, you need to create another one. So there, caching becomes very easy. You read once, never again. Ideally, you don't have to bother the ledger again. You shouldn't. It's a very popular ledger, so you don't want to ask him questions you should already know. So that becomes easy to kind of optimize for in terms of speed and less network load. Okay. In terms of benefits for the community, contextually, we need to see that Sovereign, they kind of started as like pioneers of self-sovereign identity. They were early adopters of blockchain for decentralized identity, but now they are coming to an end. I think the end of March, they are shutting down their network, and this kind of provides a solution. Some pre-existing solutions also use ACA-Py, but they talk with the sovereign network. And now we are telling them, okay, we have something which is very similar in its use case, perhaps better in terms of performance and in terms of cost. And changing it is as easy as changing one parameter in a div, at least in theory. It's certainly much quicker to do than rebuilding your entire infrastructure or your tech stack, I mean, and kind of starting from scratch. It's just a matter of swapping out the ledger layer, and hopefully I made a good case about why Hedera could be a good place to store such information. Okay, so now I want to show a demo. The code that I spoke about, so Yarrow will be open source. The ACA-Py agent also is. This plugin with the belt is open source, and the demo is as well. It's going to be not there yet, but it will be soon enough. And I think it's a good entry point if this is interesting to you, because it's easy to parse code, the demo, that kind of goes over many of the features, and it calls the agent and tells him to do different things. So it's relatively easy to play around with. Okay. Let's see the demo. Okay, before I start, this is not recorded on my computer because this is running Windows. I use Linux exclusively. But what is happening here before I start? There's going to be two actors. In the left is going to be the issuer party, maybe a university or a government. And in the right, there's going to be a holder, so one specific individual. There's some setup that is required that shows up there. It also showed up here, but it finished too quickly. But basically, they are both setting webhook listeners because they are both using ACA-Py. And they are saying, okay, if you get notified of something new, report back to me so I can display. In the terminal, it's just going to be a notification message, but you can see maybe on a website or a mobile application, you can get real-time notification of certain events. They both create their own separate wallet to store. In the case of the holder, they're going to store their credentials, but they are both going to store private cryptographic keys, which should not be on the ledger, and which are required to create an encrypted communication channel. And then the issuer needs to do some other stuff. Let's see. So imagine this is a very pretty web application. Conceptually, behind the hood, some of the similar things are going to happen. So the issuer registers a div on Hedera. We are using the testnet for this case. There's a testnet and the public net. We use the testnet here. And then we register a schema. So we say, okay, maybe a university wants everyone to know in the ledger that from now on, there's going to be this thing called the diploma. And the diploma requires a university and maybe a date and let's say average GPA or something like that. These are the required fields, much like a schema in the database. It's the same concept. And then they create a credential definition where they say, okay, remember that schema from a while ago? Okay, I'm going to publish it and it's going to be tied to my div. So if you see a credential that comes from, that ties back to me, you can use my public key so you can be sure, without even contacting me, which is an important part, that whoever gave you this credential, it is true. So, okay, this person did have a diploma. You don't have to go scanning the paper and maybe it's Photoshop, maybe not. Here you have a cryptographic assurance that something is true. Okay, so something happened now. It created an invitation object. If you were to use this in production, it will be something like a QR code, not this bunch of text you have to copy paste. So you just scan a QR code. But the important thing is this holder is going to retrieve information without going anywhere else to establish an encrypted communication channel. So this is very important in the sense that you don't have to go to an extra party, you don't have to trust their certificates of authenticity. You can go up to someone and actually say, I want to start an encrypted conversation with you. And this is basically what happens here. You kind of just copy paste here. It's not very user friendly. It's kind of a proof of concept. So you just, okay, you copy paste this. Okay. Okay, so a connection has been established. Something is refreshed here to show that a connection existed. This is the issuer reacting to a webhook firing to be notified that something else happened. And now some of your use cases pop up. For example, the ability to send messages, which I selected here. And these show up on the other agent in a way which is fully encrypted without requiring a third party to initiate it. And this message comes back as well. Okay. So now to do with credentials. Now the issuer is going to issue a credential to someone. For the demo, this is automatically accepted and eventually stored. This part is stored locally. So there's this distinguishing between what resides on the ledger public and what resides private in the wallet. There's some revocation information which is helpful for the issuer to know for a fact that the credential has not been revoked. So maybe I have a proof of residence and for some reason I moved away. I should not have it anymore. The issuer should be able to revoke it, and I should be able to prove it was or wasn't revoked to some party without the issuer having to interfere or know that it happened. So in this case, the credential is an age, 18, and the name John Smith, for example. I suppose an age isn't a very good credential because it keeps changing. So maybe like a birth date would make more sense. Okay, so now assume that the issuer has passed on, and this is now another entity. This is the verifier. This is someone, maybe a job opportunity that wants to verify something is true. Again, automatically accepted. They request to the holder, are you John? Or show me your information. Are you John? Are you 18? They send it back. And now, as long as they trust the issuer, they get cryptographic assurance that this is true. And then, after it is true, they revoke the credential. Another option, this alt this is just a pretty subjective. This is all a wrapper that goes to ACA-Py and makes these operations. The credential is revoked, so now some information resides in the ledger to let everyone know for sure that do not trust this credential anymore, and it gets challenged again, and the credential is false. Okay, so consider this kind of the back-end possibilities, and this is just an example front-end of something you can do. But you can imagine the possibilities and different web applications, maybe in an enterprise scenario with different operators, with different credentials, with different, let's say, access control mechanisms. But conceptually, it's something like this. If you have any question, feel free. Or I said everything that you need to know. In that case, that's kudos.
Can't see why people are excited. Have you gone to sovereign network applications and participants and talked to them already? Has that been done?
It's a little bit out of my domain in a way. I was mostly tasked with implementing it. Maybe some other colleague can help you better in that regard. We are approaching people, that much I know, about providing a solution which is similar in essence, and it is relatively quick for the migration. That's the important part. And it doesn't take much time, so a couple of months maybe, and the network is ending. So this is another way, and I see Hedera as much more mature, and a lot of interesting things are being done on top of it. So it is interesting. Yeah.
And the other question I have, I'm sorry. Go ahead.
No, it calls my attention that, seeing the whole AI explosion, many of the large LLMs and all of that run on Python libraries, and how this is like a cloud agent. I'm just trying to imagine all the possibilities for precisely AI agents implementing this.
Yeah, I do think first and foremost it's important to make such applications in a language such as Python, because it kind of becomes a very easy to adopt, a very easy to play around with language. It's no coincidence that Python has gained such a large adoption in machine learning areas. Definitely for me, for example, I think I started with C on college, and then I went to Python, and I would prefer it to be the other way around, because the first one is so ergonomic to work around with and so good. So yeah, in that sense, it allows for interoperability, and the choice on Python here was deliberate. I mean, there was a clear idea to use something that would be easy to pick up and integrate with other solutions. Yeah.
And somebody made a mention about my university. Funnily enough, my grad school diploma is registered on blockchain, and you can publicly verify by scanning the whole thing. So the example that you provided is very spot on.
That's interesting. Yeah, very interesting. In this case, I would think the credentials themselves do not require being on the ledger. That can be up to the necessity of the user if they want or not to publish this on the network. But to actually put that information in the public ledger, or at least having the option to do so, is very interesting, right? At least you have a more transparent idea and an ambiguous idea to know that is true. And if you put cryptography on top of it, and if you trust an entity, you can actually check that, okay, this diploma is legitimate, right? Because it was signed by someone else. And by the way, I said the example of giving a citizen card. Some places now accept my digital signature, my government signature, which is good. At least it shows that they are kind of adopting cryptographic ways that make sense and not require exposing such an important and private document. So at least it shows governments are interested in such solutions, which I think is good. Yeah.